Hi, everyone. Thank you all for joining us this morning for our virtual grand opening of the new SimCenter Detroit facility. We appreciate you taking the time out of your day and spending it with us. It's unfortunate we can't all be together right now, but our virtual event is allowing us to share with individuals from around the globe. We've had over 500 people register, representing 170 organizations in 21 different countries. We're leveraging the virtual world in more ways than one today. My name is John Kiff. I represent Multimatic, and I'm the manager of this new SimCenter facility. I've spent the past several years developing and using automotive simulators and have become a firm believer in their ability to positively impact the automotive world. Whether that be a massive reduction in the typical product development timeline, a significant improvement in the quality of upfront vehicle engineering, or as an excellent resource that improves communication between various engineering teams and delivers a truly unique experience for the end users. One of the key things I've taken away from my experiences are that people come together at the simulator. The collaborative environment is truly unlike any other. In one place, you can glean meaningful information for driver assistance systems, human-machine interface, vehicle dynamics, noise, vibration, and harshness, driveline, powertrain, battery, brake controls, the list goes on. Simulators allow for and enable seamless integration of physical and model-based design engineering in the virtual world as never before. So we'd like to introduce you to what we've been up to over the past year. Quickly though, before we get started, a couple of housekeeping items. There will be a live Q&A at the end of the event. There's a WebEx Ask Question feature that you can submit questions through at any time during today's presentation. We'll do our best to answer all of your questions at that time. Additionally, if you missed something, rest assured, we'll make a recording of this event available to all registered attendees in the near future. That said, let's get started. Multimatic and VI Grade are proud to announce the first commercially available DIM 250 in North America. This is the result of a long-standing technical relationship between the two companies, one that's been decades in the making. This story is critical to understand the why. Why Multimatic and VI Grade, why DIM, and why now? With that, I'll be passing it over to two men that most will need no introduction to. But for the benefit of those who may not know them, we have Larry Holt, Executive Vice President of Multimatic's newly formed Special Vehicle Operations Group, and Diego Minen, the Chief Technical Officer of VI Grade. Gentlemen.
Thanks, John, and thanks everybody who's joined us today. This really is truly a virtual event in every way, virtual topic and a virtual meeting. It's a really significant milestone in our technical history here at Multimatic, and it's it's a very big moment for the partnership that we've had with VI Grade over the last 15 years. For me, this journey goes way back, goes all the way back into the early 80s. I used to use MDI's Mass Inertial Dynamics software. At that time, it was called DRAM, to assess combine harvester straw walkers at Massey Ferguson. So it's a long time. I've been dealing with this software. The relationship with MDI, and specifically Michael Gattilla, when he was still there, Michael's been on both sides of both companies. That really took hold in the 90s when we were using Atoms at Multimatic to understand everything that we were involved with that actually moved, from sliding door mechanisms to complete corners of vehicles. At one point, that relationship was so strong that I traded 2 licenses of Atoms for a shock dyno. I'm not sure you knew about that, Bob. When MSC took over, that wasn't on record, and when the tokens took hold, I ended up paying a second time for those 2 licenses, but I never actually did get that shock dyno back. But the adventure that's culminating in today's grand opening really started back in 2009, when I was drawn into a concept that connected a number of people and companies that I'd known and worked with for a whole lot of years. Started with the catchphrase, desk side. Diego will remember that, desk side. That referred to a concept of a relatively small, relatively affordable 6 degree of freedom driving simulator platform that was being pitched by a collaboration between VI Grade and their hardware partner at the time. I was skeptical, but not of the basic concept of simulators. At that time, all our Formula One customers were relying on them to drive their vehicle development and ultimately their weekend setups, and they had guys, their third drivers, driving those things on the weekends to evaluate aero and suspension changes to their cars. I was pretty convinced about that stuff. We were expending as much effort at that time on developing damper math models as we were the real hardware. Pretty amazing time. My actual doubt of this whole deal was in relation to the too good to be true around 100K and an infrastructure assertion of, quote, desk side sitting on a carpet in your office, as opposed to the massive concrete and steel foundations and dedicated rooms that the big racing teams had at that time. And then towards the end of 2009, I did discuss the potential of Multimatic investing in that hardware technology, mostly due to our long-term relationship with Diego and Minin, originally through MDI and then subsequently VI Grade. That connection and that relationship, in my estimation, brought a high level of technical confidence to that endeavor at that time. I'll let maybe Diego expand on that a bit.
Yeah, thank you, Larry, for your introduction. The mutual respect, our mutual respect indeed enabled the multi-year collaboration. What happened at that time, in the basically middle of 2008, I started thinking what we could have done with a real-time vehicle model physics that we've been developing at the beginning of VI Grade. And an opportunity came with a possible local funding, R&D funding, public funding, and a collaboration with a UK-based company, which was about starting the development of a new motion platform. That basically was summarizing in a quite nice way the concept of desk side driving simulator. Larry?
Yeah. So ultimately, we didn't invest, but I remember this vividly. I was in attendance at the 3rd annual VI Grade Users Conference in Germany, in Bad Nauheim. And this was late 2010. And I saw the driver in the loop simulator working for the first time, and it was very impressive. There was no driver in at that time because there was still some safety sign-offs to be done, but still the graphics and the machine and it was everything that had been promised. And Diego and I started discussing how Multimatic might become an early adopter of that technology. Although the motion platform concept was kind of new to us, but the usage of the simulation software wasn't. And Diego and I were already constantly at that time discussing the way ahead, and that included a whole bunch of things like us scanning our development track in Calabogie Motorsport Park in Ontario, which has become an extremely famous racetrack, despite it being kind of out in the middle of nowhere, because many simulators have used it for commissioning, and we use it a lot still. We built and developed something called a parameter car, what Diego referred to as a P car, both in hardware and as a virtual model, so that we could close that gap between what we were doing in simulation and what Scott Maxwell was achieving in the real car. That parameter car was based off our retired Daytona prototype car of that era, and was configured solely with the task of accurately providing a bridge between the simulation and the real world. It was our primary dedicated correlation tool. Well, along with Maxwell, along with Scott, he was part of that. He was the spacer between the seat and the steering wheel. That process expanded into a set of wheel force transducers, so that we could close the loop on the tire testing and modeling that we were doing at CalSpan. And many days were spent in our MGS or in an MGS wind tunnel creating high-res maps for the parameter car, and on our four-post rig nailing the modal dynamics. And then VI Grade built their first SimCenter in Udine, and Scott spent many days in Italy driving his home track in Canada. And the results there were really highly encouraging. So, Diego, you want to comment on that?
Yeah, sure. That was really an early time for everything, and I have to admit that the determination and the let's say motivation that we added to the idea was complemented by the contribution of several excellent drivers, Scott Maxwell being the one that was also at the beginning quite a victim of all the iteration that normally happen. But then with the contribution of everybody, we basically even could have Larry, who is a pretty normally convinced of his idea person, that we could really anticipate the behavior of a real car working on a driving simulator. The contribution of the driver has been essential. Fundamentally, us engineers we had to convert their description of feeling, of acceleration feeling, into motor torques, acceleration profiles, actuation time, complex three-dimensional motion cueing, and so on, which if you look at the pure math, from pure math point of view, tells you little. But if you combine this pure math with the feeling of a sensible human like a driver, professional driver is really a gold mine, fundamentally. They were influencing, I would say, our concept of how the simulator desk side should have been. Obviously, at desk side, the simulator has a size for being quick and with extremely reduced latency and all other characteristics that have to be there to appreciate differences, even small differences sometimes. So we have been happy, myself and my team, to translate all those input into platform specs, and not only for the motion itself, but also for graphic, audio, body contact, and high frequency element, I would say. Larry?
So yeah, at that point, as Diego said, my skepticism, which he says I'm set in my, changed, and I became a true convert to all of this, and listening to Scott's feedback and what had gone on in Udine with the first simulator at 001 was impressive. And then something significant happened. I was on my way to Geneva for the motor show back in 2011, and Diego called me. I remember this call like it was yesterday, to tell me that the first DIL customer they had, a race team, they backed out of the purchase, and would I take them up on a deal to buy the machine and install it in Toronto, a little closer to the real track we were using for the correlation. And by the time I got around to bypass in Zurich there, we'd done a deal. We'd agreed to partner up and put the machine in service so that we could accelerate development and trying to attract some North American customers for the whole package. But I want to point out, even with that smoking deal, that 100K thing was a very distant memory. But by mid-11, so that all, we had it in-house and we got it up and running. But even with that, you know, that was just the beginning of the real climb of that journey, which is much like getting to the Barranco Wall on Kilimanjaro. The first 2 days is quite easy going, and then you get to Barranco and it gets hard. The technical challenges that we ran up against with the servo steering, which we were developing, brake paddle package, seatbelt tensioning, the graphics, all that graphic stuff, you know, that was all a challenge, but it really paled in comparison to what they call the cueing model, the actual, how the human perceives the motion, something I had absolutely I still don't have much understanding of it, but Diego does. And that's a complex aspect of what goes on in this type of simulation. And that was difficult. And ultimately, Diego's got a real grip on that in conjunction with a partnership he has with the University of Padova. So, but the price ultimately that I agreed that night, you know, in that rental car in Switzerland started to look a bit insignificant as we continued to develop the steering and the cueing, and it all jumped an order of magnitude in a bit, but we started producing really, really useful results. And many of our great products have been developed on that, on what I call bill number 002, the dampers for the Z28 and all the subsequent stuff after that. The entire Ford GT, interestingly, including all of its ABS and ESC calibration, up to probably about 85% maturity. You know, it was a tough go to talk Bosch into doing that, but once we start working with it, with their software in our loop, we were, like I say, we got to 85% of the way by the time we got Murray and Scott in the real car. And we were, you know, that was a very tight deadline in that car. And so being able to do all that on the simulator was a real bonus. So to this day, those two existing simulators, and we got another one. And we bought another one because, you know, thanks to Caterham F1 going bankrupt, we were able to pick one of them up at the auction because nobody else knew what it was. They were all buying nose cones to make coffee tables, and we ended up going out the back door with a simulator. And we use them almost daily, every day to produce and run pre-race weekend setup and for our race teams and that sort of thing. But just as that all came and planed out, and I was completely convinced, and we had to, and we were using them, and I felt we got to the crater rim, which is another Kilimanjaro reference. You think you're done, but you're not quite done when you get to the crater rim. At that journey, Diego came to visit, partially to support and directly ongoing build development, because he used to come in quite often to do that, but partly to get to Calabogie to drive the real cars, and ultimately to see if he could actually match his simulator times in the real world, which he amazingly did, actually, but not before having really massively impressive off at our hairpin. I'll maybe let him explain what happened there.
Yes, thank you, Larry. I still have a fresh memory of your face when coming to me to the scene that I'm about describing. But before that, basically all this collaboration helped me and my team figuring out what could have been also the shortcoming that we observed in that early machine that we started using for driving simulator, and we also modified during this initial stage quite massively the firmware and the software of that machine. This said, my experience in Calabogie driving the famous P car that Larry offered to me to drive with, showing a great deal of trust, fundamentally, out of the blue, knowing only how to drive a simulator, but not a real car. I was, of course, in this experience for the first time, I tried to be as cautious as I could, and also aware of the potential risk. So sometimes history is going either left or right. In this case, I went first left and then too much left, and the car was spinning, and I probably was still on cold tires. And I tried to let it spin controlling as much as possible before on the tarmac, then on the quite wet grass. My off-road experience helped maybe, bottom line, I had to be rescued because I stopped half a meter from the guardrail with a lot of grass collected, a lot of mud as well. Basically, the car was a grass cutter, more or less. And then when driven back with the rescue car to the pit, then Larry came with his sunglasses, saying, longing for off-road experience, huh? Come on, we'll clean the car, get ready in 30. And then I was again a little surprised, but I focused more, and I went in the car again for another 40 minutes. And while during this experience, having the possibility of driving quite powerful car, I developed the idea of what we could have done more fundamentally. And I realized that we need to combine the two fundamental motion of a car, that is one sliding on tires, basically on the tangent XY yaw plane of the surface you're driving on, and the second one combining the 3D motion of the chassis on top. And then this idea came up, and I was convinced that an architecture like the one of the DIM could have been the right one. And I thought it's not possible with the platform that we were using. And I found the courage to tell Larry that, yes, fine, we can continue with that, but we have to have in mind that we have to go in a different direction. And this, basically, Larry will tell you his reaction to that.
Yeah, so at that point, we apparently weren't at the crater rim. We were back at the gate at the bottom of the mountain. It was another time we were in my office, and Diego had created this new concept, and he introduced it to me. Sitting in the office, we were having lunch, and he described this I'll call it fantastical machine of mythical complexity, and you know, he's explaining. Picked up a napkin off the lunch tray, and he drew this thing, and he drew this hexapod and these three horizontal actuators, and 9 degrees of freedom, and a Blanchard ground surface plate the size of a small theater, and the platform magically suspended on air bearings, kind of the opposite of desk side, not exactly desk side anymore. And my reaction again, and I should learn. You're nuts. You're never going to get that to work. And no, Multimatic doesn't want to invest. Same answer as the first time. But here we are, and I'm pretty happy to report. I'm very happy to report that I was wrong. And Diego's DIM has become the most successful motion platform in the history of such devices. And once again, although slow on the uptake, I firmly jumped on that bandwagon once the wheels stopped wobbling. And ultimately, I convinced Porsche to buy the first machine to develop the 919 LMP1 car, which we were supplying the dampers for at that time. Then more recently, we used the VI grade DIM in Udine to accelerate the vehicle dynamics development on the AMG Project 1 very successfully. And the CEO of AMG, Tobias Moores, was so impressed when he drove it. There's now one of those installed in Alphantenbach, so I'll take credit for 2 of those. So it's become time now for DIL number 002 to be finally augmented with a DIM 250 here in the SimCenter Detroit. And now this is a proper formal partnership between Multimatic and VI Grade for the first time, not just doing stuff, buddies. It's all on paper, and ultimately I did keep the napkin, and I'm actually thinking of framing it. Thanks, Diego.
Thanks, Larry.
Wow. Thanks, guys. Really appreciate you running through that. I think that's a tremendous story, and really it shows that this center is being, effectively built on the shoulders of giants when it comes to vehicle simulation. I'd like to show you next how busy we've been over the past year with great partnership from the Michigan Economic Development Corporation, Oakland County, and the City of Novi. We're pleased to show you around our brand new SimCenter facility. SimCenter Detroit is contained within the United States headquarters for Multimatic sales, marketing, and engineering teams. Upon arrival, you'll be greeted by Multimatic personnel as you sign in for a visitor's pass and undergo the appropriate COVID screening procedures. This main entrance will be the single point of entry to the building for the foreseeable future. Adjacent to the main lobby is a large conference room that will be solely available for visiting personnel for the duration of their stay. This conference room will have access to a dedicated SimCenter network for privacy, along with virtual access to the control room and DIM 250 test cell for expanded testing activities. Through the lobby, you'll find all access points to SimCenter Detroit. The stairway through these double doors leads to the elevated control room, where floor level was purposely designed to offer a great vantage point for simulator tests. It's worth noting that for any visitors with disabilities, an accessible lift will be available for control room access. In the control room, we have nearly 400 square feet of floor space and 2 rows of available seating. We can comfortably accommodate up to 12 people for a test session, up to 8 visiting personnel, and 4 control desks for operators of the DIM. Initially, occupancy will be restricted due to COVID policy, but the adjacent spaces to SimCenter will seamlessly support whatever needs a customer may have. The control room will have hardline and wireless access to the dedicated private SimCenter network to ensure privacy and customer confidentiality. The elevated control room gives an excellent view of the DIM when in operation. This offers a great perspective of the scale of the system, clearly highlighting the highly engineered concrete foundation and Blanchard ground base plate for MIM tech necessary for DIM operation. The graphics environment is displayed utilizing 5 Barco laser phosphor projectors in brilliant 4K. The imagery is projected onto a 260-degree wraparound screen manufactured by Screenline out of Italy. Additionally, Dome Projection has installed an auto-calibration system to seamlessly warp and blend the projected image for a high-quality end product. The platform itself is manufactured by Sagonomiya in Japan. The 9 degree of freedom platform distinction comes from the 9 servo-driven linear actuators that comprise the system. 3 large tripod actuators for translational and rotational motion of the hexapod unit, and then 6 additional hexapod actuators for vertical and additional translational and rotational motion. The hexapod unit itself floats on air bearings and can maneuver on the base plate with a total translational range of 2.5 meters. The DIM platform integrates with a real-time simulation environment supplied by Concurrent Real-Time. Their Linux-based platform, along with their Simulation Workbench product, allow the parallel real-time use of up to 16 CPUs to model various vehicle systems. To supply the air bearings, incoming compressed air is filtered and dried throughout the elements along the wall. The DIM 250 and VI Grade's active seat technology consume nearly 70 cubic feet per minute of compressed air to achieve their overall performance. The large motor control cabinet houses all of the electric servo motor controllers for the DIM. At max performance, the system can consume nearly 50,000 watts of power to meet the system's demand. Overall, the complete system design can reliably replicate vehicle excitations of approximately 30 Hertz, along with translational maximum accelerations of 2.5 Gs and vertical accelerations of up to 3.5 Gs. The platform, in conjunction with VI Grade's motion queuing, offers the most dynamic virtual environment in the world. The final critical piece of the driving experience, the cockpit, is interchangeable and is imperative for immersion in the driving environment. Here we have an enclosed mid-size SUV, complete with active seat and active belt technology, active side and rear view mirrors, along with OE interior trim and a complete sim sound model for realistic NVH. To further support the operational efficiency of SimCenter, a VI Grade compact simulator will also be available. This static simulator allows for the thorough vetting of real-time models before utilizing the DIM 250 to ensure maximum efficiency during testing days. The compact simulator is built on the back of the same real-time computing technology that the DIM 250 uses, while also employing the same direct drive steering motor and graphics system employed by the dynamic rig. This room will also showcase a VI Grade desktop NVH simulator for that specific use case. Altogether, we are confident that the simulation resources available at SimCenter Detroit will meet the demands of all customers. In addition to these simulation resources, there are additional facility amenities available to potential customers that we'd also like to share with you. SimCenter has a private driver's lounge with secure network access available to escape the rigors of a testing day. When able, this will also be the dedicated SimCenter entrance available to SimCenter guests. Interchangeable cockpits can be securely delivered, stored, and prepared for testing in the dedicated SimCenter garage. When we embarked on this formal partnership, Multimatic committed to the design and manufacture of a flexible modular cockpit. Multimatic Technical Center thus produced a highly capable cockpit that accurately replicates seating position and field of view, seen here in Ford GT Mark II trim. With some additional work, this concept will flexibly accommodate everything from a single-seat race car to a full-size SUV or pickup. And finally, when we're able to spend some time together, SimCenter features a large cafe and lounge space capable of hosting a variety of events. In conference form, we can accommodate over 100 people, so stay tuned for the North American version of the VI Grade Users Conference. We certainly hope you enjoyed this virtual tour of SimCenter. We look forward to hosting your group and sharing the incredible capabilities of this new facility with you soon.
So, John went through an impressive array of the hardware and the building and the facility, but behind all this is an impressive software infrastructure. So we provide an environment, and that's installed here at the Detroit SimCenter that includes a real-time database connected to all the components, the motion cueing, the sound, the graphics, the physics model, and so on. So we have installed the VI grade versions of all this, but in addition to that, we provide, go ahead and page forward, John. This architecture, in addition to that, offers an open API through DriveSim that allows us to interface to third-party programs. That includes physics models from MSC Software, IPG, and mechanical simulation, kill systems from National Instruments and Concurrent, and graphic systems from RF Pro, and so on. So we recognize that you as users have made investments in various software packages, and we can accommodate those and fully integrate those into our full range of driving simulators. So this software infrastructure is the same through our entire range. That includes desktop, compact, static, and the dynamic systems that you saw today. So with that in mind, go ahead and page forward, John. I just want to point out that we're already scheduling visitors to come to the facility. We encourage you to come along, and you can contact either Brian here in North America or John with Multimatic. We would appreciate the opportunity for you to come and visit us and take an opportunity to look at the entire facility. Go ahead, John.
All right, thanks, Tony. I appreciate that explanation. Yeah, great product. I think, cover the importance of the flexibility to meet a wide variety of customer applications. At this point, we're going to head into our live Q&A session. I've seen a couple really good questions coming in. We'll do our best to get to them all. If we aren't able to address everything, please reach out. We can follow up offline after the event. Rejoining us on the panel for the Q&A are Larry Holt and Diego Minin. Additionally, we'd like to welcome Bob Ryan, the president of VI Grade, and Michael Gattilla, vice president of engineering at Multimatic, to the panel. With that, I'll hand it back to you, Tony, and to Mark Westaway to moderate the session.
Okay, thank you, Tony. So I've been collecting the questions as everything's been going on. So I'll read out the question, and I think Tony will then direct them to the appropriate person. So let's start here. So beyond the racetrack, where does Multimatic see or have already seen the applicability of driving simulator technology?
Michael, would you answer that question?
Sure, Tony. Thank you. That's a good question, and it gets asked quite a bit, actually. It's interesting. People often say technology transfers from race to road, and it's not just a linear process. I think most of us know it's far more circular than that. So in fact, if you think about modes of transportation, it's only within hours when people try to make those faster, and then within days they're racing each other because they're working on how to figure out how to make it faster yet still again. That's true for bicycles, it's true for cars, it's even true for riding lawnmowers. So As with this technology, I think a lot of people know about its history, and Larry elaborated on it, and Diego elaborated on it on the racetrack. But obviously, it's made its way more and more into road cars. And as that happens, we start to develop new techniques and processes that then feed back again into the racing world. In the racing world, of course, the focus is much more singular. We're always looking at things at the limit and really on the limits of stability. And when we get into the road car world, things become a lot more complex. Development cycles are a lot longer, and the systems are a lot more complicated. So when we adventured into and realized the importance and the impact of driving simulators at Multimatic, it was in principle recognition of what our core business is. Really, Multimatic at its core is a high-volume Tier 1 manufacturer of components, including suspension systems and body structures and mechanisms, including active aero systems. And we also do a niche vehicle assembly in lower volumes. And then, of course, we have our engineering organization, and Larry's SVO organization in particular is well known for what we've done in the motorsports world and also in the niche vehicle world on supercars like the Ford GT. But the reason we invested in this technology wasn't just for advancing our capability in the motorsports world, although that's a key strategic area for us. It's an end unto itself. But motorsports at Multimatic has always been a means to an end of our core business and helping us find the next way to innovate our product and bring our components and systems to our customers with a new innovation and differentiation. And we recognized early on, Larry told the story in engaging with Diego, that taking driving simulators and bringing them in would be our way of getting subjective evaluation into the loop at the conceptualization phase, which is really what's required for true innovation. And I remember very vividly the first breakthrough we had in transferring the work we were doing in simulators from the racetrack to the road was in 2012. We actually had an opportunity where we created a suspension concept for a global platform for one of our largest customers. It had the potential of saving 18 kilos per weight per vehicle, tens of millions of dollars for our customer. But it was a mid-cycle action, and it needed to be brought to market in a very narrow window. So after satisfying all the fatigue requirements, the corrosion requirements, durability requirements, strength requirements of the control arm system, suspension system at the component and system level, we needed a way, though, to hit the ground running in a very short window to make sure we satisfied all vehicle dynamics requirements as well. And we used, in earnest, the driving simulator to get everything subjectively evaluated and proven out because we only had one shot at it. That was absolutely the proof of our concept of why we invested in this technology in the first place, and the first realization where we said we would have never put that product in production for our customer under those timing challenges without the technology. And that was really the biggest transfer we had. And I'm going back now 8 years, right, from race to road. Since then, obviously, we've developed many vehicles. Larry mentioned some of them that are road car vehicles, but also road car vehicles linked to track performance, right? The Ford GT obviously is very storied in the race car end. It's a supercar as well. Larry mentioned the AMG Project One, also a supercar. Camaro Z28, track focus car. ZL11LE, its successor, also track focus car. But if I fast forward to where we are today, our focus has moved on quite a bit. And it's moved on to SUVs, crossovers, luxury sedans, and pickup trucks. And as we started to move into that regime, mainly to tackle what we call holistic vehicle development, right? Everything from the tire all the way up to the driver's eyes and ears, hands, and underside and what they're feeling. It required a much higher degree of fidelity, bigger range of motion, higher frequency bandwidth capability, and certainly vertical inputs when we start talking about SUVs and crossovers and pickups. And that's where we started to really need the ability of the motion platform of the DIM 250. And so if I look at what we're doing today and how it's impacting the vehicles that we're working on today with our partners, so we can engage with our tire development partners as we did in the race world to develop better race tires suited for a race car. We're now doing the same thing suited for what we call a holistic chassis development process that allows us to bring in those conceptual ideas very early on in the program. All things that are earmarked for road cars, really, it's a separate set of challenges, right? We have compromises between comfort and performance. Not usually worried about that challenge in a race car, but we are very much so in a road car. Worried about now when we start talking about SUVs and pickup trucks, not just on-road comfort and performance trade-offs. So how do you optimize those, but also off-road and on-road performance? Again, many more degrees of freedom. It's a multi-dimensional problem, and the simulator has been an absolutely instrumental factor in our ability to innovate there. And I would say lastly, when I think of the area of controls and electronics integration, particularly with adaptive and active systems, suspension, steering, ADAS, if you really look to the racing world, these are all technologies which, for the most part, have been entirely banned. They're just not allowed. But in the road car world, they are the key enabler in the corner. They become the cornerstone to differentiating vehicle performance, safety, comfort, and advancing the state of transportation there. And they are so complex, and the interactions are so sophisticated that I can't imagine developing those systems any longer without the use of a DIM, because there's just so much interaction between not only those systems, but obviously the subjective impressions we're trying to impart on using those. And so much like, I would say, again, going back to our history together, our long history together, Bob, and Diego and Larry, much like vehicle simulation started to become a tool that realized its promise in the 90s, and then by the end of the 90s, most of engineering organizations and OEMs started to understand you couldn't really develop a vehicle without it. We're at the stage now that our suspension systems and our vehicle systems like Active Aero cannot be developed without a simulator. I couldn't imagine working on road cars without this tool.
Thanks, Michael. Mark, next question.
Okay. How will the SimCenter be used for AV development?
Bob, why don't you take that question?
Thank you, Tony. That question aligns really well with the trends that we see in the marketplace today. So if you go back just 2 or 3 years ago, nearly all of our simulators were sold into environments where it was focused on vehicle dynamics development. But as Diego's team has expanded the application areas to advanced driver assistance systems, autonomous vehicles, HMI, and NVH, we're seeing the newer generation of simulators highly focused on this ADAS area and autonomous vehicles more and more. On the ADAS side, it's very simple. You need to understand well how a driver reacts to these automated systems. So we allow simulation users to set up scenarios like testing automatic emergency braking and lane keeping assist, and quickly see both the subjective and objective response to not only the robotic motion, but also the cues that are given by these systems, the audio, the visual, and the haptic cues, and how does the driver interact and relate to those. We need to sort those out early in the process. I think many of you had experiences with renting cars and being new to ADAS systems, and they're fairly foreign, and you're not used to them. And we want to make that much more natural process, and you can do that early on in a simulator. On the autonomous vehicle side, you have another challenge, bringing together complex sensors and actuators and control systems, all to create a safe and, if passengers are there, comfortable environment for transportation. And the simulator becomes a unifying environment for that. We can bring in hardware in the loop for sensors, for actuators, for control systems. And when passengers are there, we can put them into the simulator early on so that they get a feeling for how does this vehicle and this robotic operator behave. As you know, robotic operators aren't well accepted by many people. And so it's important that in the earliest stages of our concept modeling and design and development, we get a good feeling for how do passengers relate to those systems. So that's what we're doing today. More and more companies are adopting simulators specifically for ADAS and AV, and we see it as a continuing trend for the future.
Thanks, Bob. Mark, next question.
So you talked a lot about the parameter car. What is your confidence level of being able to correlate the driving simulator to actual vehicle performance?
Great question. Larry, do you mind taking that question?
Yeah, I guess that would be a question for me. I guess I'll give an example. I mean, we're gonna unload at Daytona on Friday with the Mazdas, and they'll come off the ramp with a simulator setup on them, and we probably won't change that. For sure, we won't change springs. We might change the front packer gap and Miller tube, depending on the air density of what the aero's doing. You know, maybe a click of damper here and there, maybe a click of wing on the rear, something like that. But what comes off that simulator is directly applicable to what's going to go on at Daytona this weekend. And you know, we don't do a whole lot of tuning when we get to the track anymore, and I attribute that all to our simulation. Certainly on the racing side, that's the way it is. And things like lap time, which is the ultimate macro assessment of what the car's doing, that lap time, if that's not within a tenth and a bit, then something's gone. We start looking at the car that there must be something wrong with the car. We don't question the simulation. We would question what the car's doing. And the same goes now with the road car. You know, Michael expounded on that quite a bit, that it's just as applicable to road car work, and we're in the middle of doing a development right now on a car, and you know, I don't think it was maybe explained, you know, Diego explained it a bit, but as far as the actual ride performance, it's the DIM that's allowing us to now really assess the ride performance, because we've got, you know, there's obviously the world has 6 degrees of freedom. We have 9 degrees of freedom. And what that is we've got 3 basically overlaid degrees of freedom on there in long and lat and rotation, yaw. And so we can have those big motions, which those actuators in that weight wouldn't allow us to actually get the high frequency content. And it's the smaller ones on the hexapod that are getting, you know, we basically got a superposition of, say, lateral, where we get this large G input, but at the same time we're getting a high frequency content at the same time. And you can't do that 6 degree of freedom, a normal 6 degree of freedom machine. And so we're out there doing a vehicle development right now where we are doing the ride performance aspect of it as well, and we are getting direct. I mean, the place that we see that a lot is when we're doing post-predictive analysis, and there's a problem in a vehicle that somebody brings to us, and we can actually replicate it. And a bit of what Michael was talking about earlier with that suspension development was exactly that. There was a very, very subtle ride problem that we generated because of a small stiffness change in a rear link in the vehicle that you could pick up on, and we identified it and replicated it on the rig, and then solved it on a simulator and a DIM. So I would say the answer to that question is I have an extremely high confidence level in what comes off our simulators, and that and if I didn't, we wouldn't have won 3 races with the Mazdas last year.
Well, I think that says it all, Larry. Winning is where it matters. Mark, next question.
Other than vehicle dynamics, what other attributes can be studied at the SimCenter?
Hey,
Diego, that sounds a good question for you. Do you mind taking that?
Yes, obviously, one thing that a passenger car could be less interesting in terms of vehicle dynamics than a more sporty car could be. But in fact, if you think about driving assistance system or even autonomous car, which is the direction we're going to, in reality, the human brain is a lot distracted by visual due to all these aids you receive, and one tends to perceive the car with its motion. And of course, when you have a robot controlling the car, the action of the robot are kind of not so natural. So everything that is odd, you know, that's thinking about an AV development, is a problem for a standard driver, not talking anymore about a professional driver, which feels kind of weird while watching, sampling the visual from time to time and feeding the car with his body on. So it's very important that we have dynamics there, and accurate dynamics, because control system, robot action are not negotiated by what happens in the environment, are just driven by certain input by definition have to be kind of simplified. So we see a lot of value in doing all that on simulator. That goes beyond vehicle handling only, that is basically comfortable dynamics of a human being inside the car.
Thanks, Diego. Great answer. I guess that's subject for the next webinar. We can talk more about that. Mark, next question, please.
Yep. So hopefully an easy one. Where is Sim Detroit located?
Michael, I think that's a great question for you.
SimCenter Detroit is located in Novi, Michigan, and which is about 30 miles outside of Detroit, 35 miles west of Detroit. And it's easy to find on a map. For people who don't know, Novi is N-O-V-I, and there's some history there. It was a train station, and it was station number 5. So that's the genesis of the name of Novi, and Roman numeral 5 obviously being the, 4, sorry, being the VI. And there's a VI grade connection there. So 6, train station number 6, sorry, I got my math wrong. You check me on that. But anyway, you can look us up on a map. It's very easy to get to, very accessible from Detroit Metro Airport, and we're ideally located as well in and around the technical centers of most of the major OEMs in the area.
Thanks, Michael. Next question, Mark.
How are you able to obtain 3.5 Gs of acceleration on the simulator?
Diego, do you mind taking that question?
Yeah, I can pick up this question. Obviously, we are talking about small travel high frequencies, because if you want to sustain 3.5 G on a driving simulator for, say 10 of a second or a second, you will need a lot of space. And then, of course, when you have to build a too big simulator, then all the characteristics, most important characteristic to perceive short transient is gone, because you have to build a super big machine that intrinsically has a slow dynamics. So you can do high acceleration at high frequency short travel with the D250.
Thanks, Diego. Mark, next question.
What level tire models do you find are necessary to evaluate vehicle handling performance consistent with in-vehicle testing? Are the Passaica MF models adequate? Do you recommend a specific use mode is necessary?
I'm looking for a volunteer for this question. Who wants to answer? Michael?
I'll take that on, sure.
All right.
With all simulation, of course, the fidelity of the systems that are modeled have a big impact on accuracy. Larry and Diego touched upon that, Larry more so about correlation. So it depends on the events you're obviously running. There's a whole family of tire models that exist out there. Some are ideally situated for more handling behavior maneuvers, some for ride comfort, and some now are starting to get into off-road models with deformable terrain. Like all engineering tools, there isn't one tool that is the magical tool that solves every problem. But when looking at usage cases and looking at vehicle performance for the environment in which you're trying to recreate on the simulator, the accuracy of a tire model is fundamental. Obviously, it all ends and starts there where literally the rubber meets the road, or the sand or the dirt or the gravel. So tire modeling has always been a key to offline simulation accuracy, and even more so to the simulator, because we're looking at, in many cases, things that are far more subtle. And one of the things, just to go back to one of the earlier questions asked to me about the benefits of this outside of racing, one of the surprises, I would say surprise and delights, is when you start to venture into doing driver in the loop simulation, you realize and you raise the level of accuracy and fidelity of your offline simulations. what you thought was a really well correlated model offline because you're matching squiggly lines, objective data all the time, starts to become apparent that when you're trying to get into the nuances of on-center steering, for example, that there are things that are missed that you didn't realize in your offline simulations. And by improving the accuracy, starting with tire models, but also damper models and suspension and compliance models, friction in the steering system, EPAS systems, all of those things add up to a much higher degree of accuracy in your offline simulations as well. And I think that's a benefit we realized early on, and I think most people who've been involved with driver and loop simulators have realized the same thing.
Initially, you were somewhat restricted on real-time simulators with driver in the loop to very simple tire models. In the last few years, all of those restrictions have disappeared. So this simulator supports all the standard tire models, the Swift, the Magic Formula, as well as the CD tire and F tire for developing systems. So you can pretty much use any tire model now in a real-time environment. It's been a lot of effort to get to that stage, but now you have to pick the tire model that best fits your application, and we've made sure that they can work in real time with driver in the loop. So it's a nice advance and allows you to get the real detailed accuracy that Michael was speaking about.
And if I just may add one more thing to that, it's not about getting a tire model so the tire is a static thing, that you quantify what it is so you can get a better simulation. It's actually about helping to develop the tire itself. So with our partners in the tire manufacturing world, we are also working through the tire model to be able to define parameters that then lead and enable them to create innovation in their structures and compounds that add up to the tire capability for a large degree of problems those things are trying to solve, right? It's not just handling, it's noise and comfort and wear and many issues just around the tire itself.
It may not be obvious, but one of the low-hanging fruit applications for driving simulator is in selecting the tires and working with your tire manufacturer early in the process, because that process is a lengthy process if you have to go out to the track and have all the tires shipped there. Doing it in a simulator is much simpler, much easier, and faster. And so our initial customers cut their teeth on choosing tire parameters for their new vehicle launches. And that's been a starting point for most of the top Ds of simulators.
Thanks, guys. Great answers. Again, it's a good topic for another webinar. We're going to take one final question. We're not going to get to everyone's questions. For the ones that we didn't get to, we'll reach out to you and answer those. So we definitely appreciate the interaction. There's some great questions. So Mark, one last question, please.
So you mentioned NVH a couple of times during the presentations. Is there a connection between NVH playback quality and evaluating a vehicle for ADAS, HMI, and vehicle dynamics?
Did you understand that question, Bob? I'll let you start out. Maybe Diego can chime in.
Yeah, I think initially NVH was not a topic that was taken on by driver in the loop motion platform simulators, and that's all changed, I would say, in the last year and a half. Initially, these driver in the loop simulators were oriented towards vehicle dynamics, as I mentioned earlier. We realized that it made no sense for two different groups to be doing development with the same parameters, the same vehicle, but in a different way. And so we've made a concerted effort at VI Grade to link together with really the best in the industry at Brüel & Kjær. So we've united the Brüel & Kjær team into VI Grade so that we can deliver a unified environment for NVH, ride and handling, HMI, and ADAS. You're starting to see the fruits of that already in the simulators with SimSound, and you'll see more and more of that in the years ahead. Diego's team is working full tilt toward a unified concept for NVH and ride and handling so that you can do that development together. I don't know if you want to add something to that, Diego.
I think it's fine. You put the right words on that. Clearly, this goes back to the multisensorial experience, especially if you think about putting more normal people between quote normal on a simulator, and you miss some of the what I call full spectrum, acoustic and vibration, and body pressure experience, then always something is missing. So by increasing the level of realism, you can also judge the single aspect more accurately, because you are in an environment that is that resemble reality better, and then you can identify issues better. That is the scope, and thanks to this, let's say, conjunction of technology and expertise, I think we go to the next level, really, as Bob said.
I'm pretty sure there's another napkin out there with another drawing that Diego has in his mind for the next creation. So we look forward to that napkin.
There actually is one.
All right, excellent. All right, hey, I appreciate the panel, some great questions. I appreciate the interaction from the audience. John, do you want to sign us off?
Yeah, sure thing. Yeah, thanks everyone. Thanks to all the panelists. Thanks to everyone for the interaction. I'll just echo what Tony said. And thanks for your time today. Sorry we went a little bit over, but we appreciate your time. Thanks again, everyone. Wish you all the best. Stay safe, stay healthy, and look forward to seeing you soon.